Hello everyone, welcome back to my channel Learn with Simran, where we dive deep into the world of data science and machine learning. Today we are going to talk about the two of the most fundamental types of machine learning, supervised and unsupervised machine learning algorithm. These are the building blocks of machine learning algorithms, and understanding them is crucial for anyone looking to get into the data science. So let's get started. Let us first talk about supervised learning. In supervised learning, the model is trained using labeled data. That means the input data comes with the correct output labels, and the algorithm learns to map inputs to the correct outputs. Essentially, it's like a student learning under the supervision of a teacher. The algorithm is supervised by the labels provided in the training data. You feed the model input-output pairs and it tries to learn the relationship between them by minimizing the error between its predictions and the actual results. Now, there are two main types of supervised learning, classification and regression. Classification is when you need to predict a categorical outcome. For example, imagine we want to predict whether an email is spam or not. That's the classification problem, where the result is a discrete label, spam or not spam. Algorithms used for classification include logistic regression, support vector machine, and decision trees. On the other hand, regression is used when we need to predict a continuous value. A classic example of this is predicting house prices based on features like square footage, location, and the number of rooms. Popular regression algorithms include linear regression and random forest regression. Now, let us look at a real-world example of supervised learning in action. Imagine a hospital using machine learning to help doctors detect breast cancer. The hospital has historical data where tumors are labeled as either benign or malignant. This is a perfect example of classification problem. The hospital uses a model like random forest or support vector machine to learn from this labeled data. Once trained, the model can predict whether a new tumor is benign or malignant based on input features like tumor size and texture. This tool can help doctors make quicker and more accurate diagnosis, potentially improving patient outcomes by enabling earlier treatment. In your screen is a very good example to understand supervised machine learning. For supervised machine learning, the input is a labeled data. Here, the carrot, tomatoes, and bell pepper. We use this labeled data to train our model. And the test data, which has no output as of now, is used to predict and check whether our model is performing well enough or not. Now, let us move on to unsupervised learning. Unlike supervised learning, unsupervised learning deals with unlabeled data. Here, the algorithm tries to find patterns, structures, or relationships in the data without any predefined labels. In other words, the algorithm is left to its own devices to discover hidden structures in the data. It's like giving the algorithm a puzzle without showing it the complete picture. There are two main types of unsupervised learning, clustering and dimensionality reduction. Clustering involves grouping similar data points together. For example, an e-commerce company might want to group its customers based on purchasing habits to create personalized market campaigns. Common clustering algorithms include k-means or hierarchical clustering. Dimensionality reduction is used when you want to reduce the number of features in your dataset while retaining as much information as possible. This is useful when you have a very high dimensional dataset, like images. Popular algorithms for dimensionality reduction are principal component analysis (PCA). Now, let's dive into a real-world scenario for unsupervised learning. An e-commerce company wants to understand its customers better, but they don't have predefined labels for customer types. Using unsupervised learning, the company can use k-means clustering to group customers based on purchasing behavior. The algorithm might group customers into segments like frequent high spenders or occasional bargain hunters. This allows the company to target these customer groups with personalized marketing, leading to higher sales and better customer retention. Here's a very good example for unsupervised machine learning. Here, the raw data is unlabeled, unlike supervised, which has labeled data. We give this raw data to our algorithm to make sure it predicts by clustering it into different segments. So, what are the key differences between supervised and unsupervised learning? In supervised learning, the input data is labeled, whereas for unsupervised, it is unlabeled. The goal for supervised learning is to learn a function to map input to output, whereas for unsupervised, it is to discover hidden patterns or structures in the data. The use cases may involve medical diagnosis, stock price prediction, and for unsupervised, it will be customer segmentation or anomaly detection. Supervised learning is simpler and more interpretable, whereas unsupervised learning is complex. Supervised learning requires large amounts of labeled data, whereas unsupervised learning can work with unlabeled data, but results may need manual interpretation. In short, supervised learning is great when you have labeled data and need a clear output, whereas unsupervised learning is useful when you want to discover hidden patterns in unlabeled data. To wrap up, both unsupervised and supervised learning are essential techniques in machine learning toolkit, each with its own strengths. Supervised learning is perfect for problems where you know the outcome, like classification or regression tasks, while unsupervised learning is ideal for exploring and discovering patterns in the data. So that's it for today's video. In case if you have liked this video, do like, share and subscribe to my channel Learn with Simran. Thank you so much for watching. Keep learning. Bye bye.